It looks like page.
Was Aaron Rodgers playing against your pick to win the NFC? Wasn't it? That's not important.
Hello, everyone.
Hi.
So please go ahead and mute your microphones if you can. So we are going to get started today. We have a new topic this week, which is modules. I kind of went over it last Thursday. We covered a little bit of it. So before I get started, I just want to see if there's any questions about anything. You want to bring up any questions? I believe your first homework assignment was due last Thursday, and the Dropbox should have closed by Saturday on the Brightspace. So I assume everyone submitted. You know, I'll take a look at that assignment probably sometime this weekend, when I have a little bit more time. And so now hopefully you have a feel for what we're doing. So this week you have a new homework assignment due by Thursday, which is the conditional structure. So far we've done 2 homework assignments. That's it. We've done the inputs, outputs, and variables. That was 1. And then we did the, as I said, decision structures. Remember, with these, all you're doing is the PDF. I usually post the PDF, a PDF with the problems. You have to check because some of them will say programming assignments, some of them will say debugging, and they might have the same number. So there might be a number 3 in debugging and a number 3 in workbench and a number 3 in programming exercises. I will usually say which one of those categories you have to work on. So remember that, please. So usually I'm writing the problems, 4 to 5 problems, depending on how long I think they'll take. So I'm writing the problems on Brightspace, and then you have to reference that PDF, okay? Now, they might be coming from lots of sources, so that's why I'm putting the problems there, because it could be problems from any of the books, or it could be from other books that I have, you know, etc. All right, so I think everyone is in now. I've seen everyone flowing in. So you should be seeing the current slides. We're doing, you know, this week we're doing modules, so it's several chapters actually, but it's very short chapters is what it is. So we're going to be doing modules. Then we will be doing functions, which I kind of hinted at. Python is mostly about functions anyway, and so that's kind of the focus that I want to take. And then we're going to do the, you know, like from the Python book, also where it addresses modules and functions. So before I get started with today's lecture, are there any questions? No questions? Okay. As I said, you can always email me and Mitch, and you know, any questions that you might have. One thing I wanted to remind you of before I forget. We are currently on week 4, if you notice. So this is week 4. That means we're starting to get into the semester. Usually I would have had a few more pop quizzes or little things like that in class, but given that we're not there and it just lot harder to submit assignments online, etc. So I haven't had as many little quizzes and things like that, but we will have our first exam. It's coming up, okay? So I do want you to be reminded of that. We will definitely have our exam 1, and it'll have to be most likely a real-time exam that we will do on the computer somehow during the class period. So it'll be on a Tuesday, pretty much at this hour. So from 12 to 1:40, I will give you an exam, and you will have to be on the computer taking it. You know, it's not going to be multiple choice. At least it won't have that much of that. I usually like to have at least 60% of the exam be problems, pretty much like what we have done in the homework assignments and the lectures. So it'll include everything that we cover up until next Thursday. So as I said, this is week 4. So everything that we cover up until the end of week 5 next week. And then the exam will be on the Tuesday of week 6, which if I'm going to give you a date and mark this, I'm recording the video, so it'll be in the video for you to look it up later, but be aware of it. Currently, today's September the 15th. This is week 4, week 5, and then week 6. So it'll be September the 29th, okay? Exam 1. Are there any questions about exam 1? Are you guys there? I usually get questions about exams.
I'm here.
Yeah, okay.
Yep.
Well, okay. If there's no questions, if it's clear, that's great. But we will have exam 1 on the date I just gave you, September 29th. So start studying for that. Remember, you will have an hour and 40 minutes, and you can expect a few problems in there. Well, you know, it'll cover. So this week we're going to cover modules. Next week I'm going to start iterative structures, which are loops. So I may not finish that, but I will start it. So a little bit, whatever we cover of loops, certainly modules, we'll get through it this week, no problem. I mean, you already know it in a way, given last Thursday's problem. But yeah, that's the plan. So you can expect on the exam, you know, I'll ask you, okay, do the flow chart for, you know, I'll give you a problem and then I'll say, do the flow chart for this. Or I may, because, you know, you don't have that much time, right? So, or I may just say, do the pseudocode for this. Or I might say, do the Python code for this, you know. So I'll be looking for, I'm usually pretty relaxed when it comes to syntax. I'm mostly looking for logic and pseudocode, but just, you know, I always tell students, if I say, you know, write the code, probably mean Python, unless I mean like C, C++, and you have to write it, or, you know, like web stuff, you know, JavaScript. and so I'm going to ask you to just write it as much as you can like Python if I say code. But if I say pseudocode, you will have to use the reserved words that we have learned so far this semester. And as I said, but the main thing is I'm looking for your programming logic, you know, your design, your process. All right, so no questions, it seems. All right, so it seems like there's no questions, so let's get started. But your homework, your exam is now assigned or scheduled, rather. Okay, so chapter 3. So as you saw, you know, I don't exactly follow the flow of the book all the time or of the books. I always like to keep things, you know, fluid. I like to get into if statements really quickly. I feel that's, you know, kind of fun to get you guys to do that part. So we did that. So we covered inputs, outputs, and variables. You understand that process basically, very basic, almost the hello world basics. You understand the basics of variables in general, you know, that you have to declare data types. And then there's, in Python, you actually don't explicitly declare data types, but the variables do have data types, right? And we talked about that. Main data types are, you know, integer, float, Boolean. What would be the fourth one?
String.
Very good. All right, and so all right, so I just got a question that some of the problems were lengthy. I think I only gave you 4 problems for this homework assignment, correct? Instead of 5?
Yeah.
Yeah, and I did that intentionally because I knew some of these were a little bit longer. I usually try to give you 5. You know, I kind of measure how long it'll take. So, you know, some of the time, it's not always, so let me put it this way. It's not always going to be like that problem, okay? So, you know, there's a reason why sometimes you're given all of these things, right? So there's this reason for one problem or over another problem. Certainly you can shorten them if something is very repetitive, but at the end of the day, I think the idea is to illustrate to you guys that things that are repetitive probably are best candidates for automation somehow, right? And that's why we learn for loops and things like that. It's because, you know, these problems are meant to show you that, you know, maybe the way that you're writing them sequentially is not efficient, okay? And so that's really the idea. So, you know, work through the problem, do your best. Can't be that, you know, that bad. But, you know, within reason, of course. But as I said, not all problems will be that long, but I did consider, that's why I only gave you 4 problems this time, because I thought, okay, some of these are a little bit tedious, okay? In the future, I may also just give you fewer flow charts, and, you know, as we start progressing in our abilities of Python and everything, you know, you'll see that maybe you don't need the flow charts that much anymore. And so we might start to progress more to code, especially when the code gets a little bit more complex. Okay, so let's get started then with modules here. Okay. So as I said, you know, this is what we discussed before last week, defining and calling a module. We've already sort of hinted at that, and we are going to look at that again. Local variables. Local variables, to me, are Python is such an easy language, and yet variables, especially the opposite of local variables, which is global variables down here, for whatever reason, it's always a complex thing. I can almost say that I don't really like the way that Python does global variables. And as I've said many times, I seldom use global variables in Python because the solution is really to just use local variables. You got to be very strict about that. You know, and I think intentionally, Python is probably designed like that you should not use global variables. There's very valid reasons why. I mean, they're not bad, but there are some people that are very strict about that, and they just don't want global variables in there because they feel it's, you know, sloppy coding. So I think that's why Python makes it that way, where it's a little bit complex. at least in my opinion. And so the tendency is to make everything either a local variable or to use object-oriented programming, which is really what you end up doing anyway when it starts to get pretty complex. We will look at this topic towards the end, and this is something that you will look at many times later in many other courses. So this one is really a little bit outside of the scope of 140, but we will still touch on it. Okay, but the issue of variables comes back when you're dealing with modules. We're going to look at something called bival and biref. And this, although this exists in the underlying, the underlying C, implementation of Python, it's abstracted quite a bit in Python to the point where we don't explicitly use it. Okay, but it's a top. This is more of a topic that's a general topic. So this is a general topic for all programming languages, and in particular in C, C++, this is extremely relevant. And when you guys take your course in C, C++, which is an extremely important course that I recommend you pay a lot of attention to, their bival, biref, which is this idea of passing arguments to modules, will become very, very important, right? But for our purposes, because as you know, I think I've stated this many times, C, C++ is a very low level, but we are doing Python, which is a higher level language with more abstraction. And so basically it's a little slower, but only because, and that slowness though makes your life a lot easier in just really quickly prototyping and programming things. All right, so these are the topics then: defining and calling a module, local variables, passing arguments to modules, and global variables and global constants. So initially though, when you're starting to program, you should use global variables. I don't want you to misunderstand. I don't want you to overcomplicate things. When you're starting out, everybody uses global variables. Use them extensively if you want to. As you progress, you will start to see, as you have more functions and more things going on, you will see the strange behavior that Python has. That you have a global variable outside of the functions, you can sort of access it and read it, but writing to it becomes a little bit odd. And so that's why it's better to pass values through arguments into functions, return, and then outside of the scope of that function, try to return things to the global variables. So that's probably a more recommended approach. But we'll see that. But for now, definitely use global variables. Just be aware that, especially, I guess that note I said is for those of you that have already used programming languages, because when you start trying global variables in Python, you'll see an odd behavior. All right, so let's give the module a formal definition. So a module is a group of statements, and remember, a statement is just a line of code, right? So statement is line of code. So a module is a group of statements that exists within a program for the purpose of performing a specific task. Okay, so you kind of want to group together things. So if I want to, I want to have a print function, and that print function is actually not the original print function, but my print function, where I have several prints. I want to print, name, first name, last name, address, phone number, zip code, all that stuff. And it's kind of a group, right, of statements as this defines it. We also saw We also saw that last week that there was an advantage in using modules, that instead of you having to repeat the same set of lines of code over and over and over and over, now you have you know, one block of code and and you reuse it. So that's called code reuse. And that's a very desirable feature in programming because it reduces the amount of code that you have to write. So most programs are large enough to be broken down into several subtasks. And that's really, you know, that's how we solve problems in life, right? You have a complex problem. Let's say that you have you're building a computer, right? You're building your PC at home. You know, you're not gonna, you have your laptop, but you want to have a more powerful computer. So, you know, probably economical to just build it yourself, right? And so you start buying the pieces. Even if you don't know how to do things, what you're going to do is you're going to take the parts that you bought, group them. You know, these parts are for this, these cables are for that. And you create these subtasks. So first I'm going to build, then I'm going to connect the cables. Then, you know, I'm going to power it up. Then I'm going to run the OS, install the OS, and so on. So in life, we do that. We break everything into subtasks. Programming is no different, okay? You saw how I was writing the program actually on Thursday, that I don't actually like to start from 0 to 100%. Instead, I write like 3 lines of code. Make sure, you know, what I call the pipeline, right? You know, pipeline, what I mean by pipeline is it's got an input and an output. And so I want to make sure that water flows through that pipeline, right? And it doesn't leak anywhere before I start exchanging parts with other more complex parts. And so that's, you know, that's how you want to do things. You know, here you have this famous quote, right? Divide and conquer. It's easier to tackle smaller tasks individually. So you should do that. You know, start with a little bit, get it working, then start adding to it. Okay? It's the same with writing, right? You're not going to write a book from page 1 to page whatever, 500. You write some headings and you write some topics and then you elaborate, and you're always refining. So another way of looking at a program is that it's like a diamond in the rough, right? So you're, you know, refining that rock until it's pretty shiny. Okay? So that's what a module is. It's kind of it's actually called modular programming. So it's not just a construct in programming, but it's literally a style. It's literally a style of programming that you're doing. Okay? So think of maybe a good analogy is for those of you, you know, like the space program, right? Imagine that space capsule that went to the moon. So that had a lot of subsystems, right? You know, press this button, you know, activate some kind of subsystem that runs, press this other button, something else runs. So it's modular programming. You're literally putting in modules in there that do specific tasks, and they have usually inputs and outputs, right? And so the input of it is the output from something else, and then this module's output goes to something else as well. So what are the benefits of using modules? Simpler code, quite simply, simpler code. Small modules are easier to read, and that's very true. Code reuse, this is, you know, the one I stressed last Thursday. I didn't want to write all that set of flowcharts and statements, right, in pseudocode. And so you just reuse the code. If you know that you're going to be using that my print function several times, or you have a performance metrics function that you're going to be using all the time, well, go ahead and reuse the code. Also better for testing. All right, so you test separate and you isolate and then fix errors, right? So instead of, you know, you have all the code from beginning to end and it breaks here. If you have a module in here and that's where it's breaking, now you don't have to test all of this and all of that. You just test this part here, right? So that's, you know, it makes things better for testing. Faster development because you reuse common tasks, right? You're, you know, as I said, you know, get into the habit of creating a GitHub account. So create GitHub. You've never heard of it. Create your GitHub account and then start, just create a, you know, a folder in there, a repository, and just say, these are my simple Python scripts, so on. Start building that, right? And then you can actually reuse your own code. Whenever you're writing something and you know you've done it already, you can just go online really quickly and say, oh, here it is. And you already wrote it as a function, you already wrote it as a module, so it's actually ready to use. And then the last part is easier facilitation of teamwork, share the workload. So once you know how to write a program, you divide it into the flow charts, the pseudocode, the modules, and then you just say, okay, you know, that, you know, this person handles these 5 modules, this other person handles these other 5 modules, and so on, okay? All right, so that's kind of the motivation for modules. Now we're gonna get into the specifics of it. So are there any questions before we continue? Questions? No questions? All right, so the next one is defining and calling a module, okay? So we saw this a little bit last week with functions. Here we're using just the more generic module keyword. So this is called, the code for a module is known as a module definition. You can see here, you use the keywords module and then end module. The statements go in here, any kind of code that you want to write, and then just notice you give it a name and you will use the parentheses to indicate that it's some kind of a method that's going to run. Then when we, in the pseudocode, when we want to execute the module, you will write a statement such as this one, call show message, okay? So a module's name should be descriptive enough so that anyone reading the code can guess what the module does. No spaces, no punctuation, and it cannot begin with a number, right? So those are just some general rules. Obviously in the pseudocode, you could write anything, but as you start implementing it in Python, for instance, you will see that some of these things it won't allow you to do. Punctuation is not allowed because punctuation is reserved for object-oriented programming. And so you will not be able to use that in Python for anything else. Punctuation just means the period. So defining and calling a module, definition contains 2 parts, the header, or a header, the starting point of the module, right? And the body, the statements within the module. So you can see that, you know, you have statement, etc. And then you have basically these headers. Notice the indentation usually, and that's going to be essential in Python. So defining and calling a module, a call must be made to the module in order for the statements in the body to execute. So that's a good point, actually, that just defining the module, just believing, hey, I wrote the module in there, does not actually run it. You know, the idea with modules is that you can define them but not use them if you want to. You know, it's like you have, imagine you have a list of helper functions. You have 10 functions, and on Tuesdays you use 3 functions. On Wednesdays you use the other another 3 functions, and that's the idea there. And so when you're doing this, like you can see here, we have a module main, and main is, as I said last week, kind of the where you would start, if you will, although you don't need that in Python. C does have it. And so then you can see you have a statement over here, but here you have a call to show message, which is this one. If you didn't have that in there, let's say that was not there, then even though you have this code, the program won't give you an error. It will just ignore that function. So it's not going to display hello world. It will only display, I have a message for you, and then it's going to display, that's all, folks. Okay? And so because you didn't call the function, even though it was defined. Now, if you do leave it in there, then it's going to, you know, I have a message for you, then call show message, which means it's going to execute whatever's in here. So it's going to display hello world, and then it's going to display that's all, folks. Okay. Now here we can take a second now to look at an example of flow charting. You can see that there. So defining and calling a module. When flow charting a program with modules, each module is drawn separately. And we saw this already in an example last week. That's why that example was so great, actually, because it covered a lot of topics, but topics that are really very intuitive. Okay, so we can see here, the idea is you start with this symbol. That's the name of the module. Then you have the end, and then in between you have whatever, you know, whatever statements you want to have. And the important symbol that we saw last week was this one, this sort of rectangle with lines like that. And that's basically a call. And then over here we have the function that we're calling, again with the name. And if it's a function, it has a return, as we have seen already. And then whatever statements go in there. So pretty straightforward, really, and quite intuitive. All right, so defining and calling a module, a top-down design is used to break down an algorithm into modules by the following steps. So you start at the top, right? So, you know, you start at the top. You start there, kind of work your way down. So a top-down approach, the overall task or the overall problem is broken down into a series of subtasks. Right? So you take the big picture, the big thing, and you kind of break it down into things that seem common, and you just start sort of slowly trying to figure that out. And then each of the subtasks is repeatedly examined to determine if it can be further broken down, right? And then once you find groups, you have to break it to a logical conclusion. And then after that you have identified the subtasks, you write, you know, your flowchart pseudocode, and then you can start coding, you know, maybe in Python, and then eventually you run that, you debug it, and then you figure out that it's ready. And remember, then you send it to your developers, who will probably develop it in a combination of C, C++, or some kind of a web application. All right, so so here, let's take a look at this. So defining and calling a module, we can create a hierarchy chart which gives a visual representation of the relationship between modules. So this is, in particular, this might be important when you have a lot of modules, right? And you just kind of want to picture the relationship. And so you exclude the details of the entire program. So this is, you know, when you're developing some kind of a system. Okay, let's say you're talking about payroll or purchasing, some kind of a system like that. You're going to have a lot of functions to calculate taxes, calculate benefits, calculate net pay, calculate withholdings. So this seems to be a payroll. Calculate overtime, calculate gross pay, hourly rates, hours worked, get input. So yeah, so this is a payroll system. By no means is that all of it, but that's certainly you know, some important functions, and so you start to create this hierarchy that allows you to group things as you're breaking it down into individual pieces. All right, so now we get to this idea of, as I was talking about, variables again, but in particular, we're actually talking about this keyword, scope. So that's important because, as I said, you know, there's quite a bit there. So a local variable, so let's give some formal definitions. A local variable is declared inside a module and cannot and should not be accessed by statements that are outside the module. Usually by default, programming languages will restrict it. So if you declare something within a module, and Python in particular, it's going to, you know, it's going to say, okay, this is within a function, that the scope of that is just that function. So the word scope actually describes the part of the program in which a variable can be accessed, right? And only there. Okay, so functions have a strange behavior where in memory, we're talking about the computer memory, they are stored in a place called a stack. So every time it's like I'm in function 1 right now, so its variables get added into that part of memory. But the second that the function is not used, the data might stay there, but the link is gone. So effectively, the data is gone as well. And then you get another function, let's say function 2, and then it allocates another segment in memory. It lives there for as long as the function is there. Again, once the function returns, you know, you break the link. So variables with the same scope must have different names, and that, you know, that's pretty clear. That's, so if you have a couple of variables in a function, you know, you're gonna have X and Y. You can't have two of the same name, otherwise you're basically just running or processing the same variable. Now, here's a topic that sometimes it's a little bit abstract. We won't be using this that much in Python, to be honest. This is more extensively used, in, as I said, in C, C++, and other programming languages. All right, the idea of passing arguments to modules and how we do that. So I should say we're going to pass modules. We're going to pass arguments, but the way that we pass them, whether by ref or by val, you know, by val or by ref, that's a topic that it's a little bit more outside of the scope of this, but we will touch on it. So let's talk about arguments. So sometimes one or more pieces of data need to be sent to a module. And that's what I was saying, that is usually preferred to having a global variable. So you have a function, you know, my function, and then there's a variable over here, a equal 3. And then in here you have y equals a plus 2, right? So, you know, the idea of a global variable is that this would be a global variable. It's outside of the scope. A preferred method might be to pass the variable as an argument. This, you know, variables within parentheses like that are called arguments. And so this is the preferred method, okay? Doing it like that. and then this would return y, let's say. Okay, so when you call the function over here, my function, you would, give it 7 or whatever, but whatever you put in there goes into A, and then A becomes that, okay? So we'll see that. That's kind of the general big picture of all of this in this example. Okay, so an argument is any piece of data that is passed into a module when the module is called. A parameter is a variable that receives an argument that is passed into a module, okay? So again, let's look at these definitions. An argument is any piece of data that is passed into a module when the module is called. A parameter is a variable that receives an argument that is passed into a module. They're all variables. So it's more of a semantics thing that we call it argument or parameter, just so that we know specifically what position it serves in the program. But at the end of the day, they're variables. The argument and the receiving parameter variable must be of the same data type. Now, this is important, as I said, with strongly typed programming languages. With Python, as you know, Python will just simply change the type, right, depending on the data that you give it. You give the variable. Multiple arguments can be passed sequentially into a parameter list as well. Okay, and there are various ways of doing that depending on programming language. So let's take a look at this idea now. Passing arguments to modules. So it's kind of what I drew in my Scratch handwriting before, which is now written much clearly here. So we have 2 arguments passed into 2 parameters. So the idea here is that once again we have module and module. We have the main function over here. We have display, that's a print statement basically. And then we have a function, a module that we have defined called show sum. Okay, so we have a module called show sum. And notice over here we have 2 arguments basically, num1, num2, right? And we're explicitly defining the data type, integer. So, this is not required in Python. However, when you're doing pseudocode, I will ask you to do this. It's almost like a comment that you will be doing, but it'll just be very useful. And as I said, when you move to other languages, you will definitely have to do this. But right now, it takes the complexity away a little bit in the sense and lets you focus on other little details and on other details. So we have num1, num2, and then in here we have declare integer result. And so as you can see, we take the parameters num1, num2, add them in that statement, and then display the result. Over here on the main, this is the first thing that would execute, right? When we run this program, it would call sum, and notice that it takes these values 12, right? And it passes that to num1, and 45, and it passes that to num2. All right, so you can see that there pretty clearly. Any questions about this so far? No question?
So 12 and 45 was already in the module. So when they went to the set result from num1 plus num2, it was already there.
Right, so remember, you define this, right? And you define it with variables, num1 and num2. But that, when you define this piece of code here, it has no actual values. It is only like a placeholder. It's like you're saying, I'm going to put something there. I just don't know what. And so the way that that's the only thing that you need to define, because once you put 12 here and you put 45 here, you know, this will have a 12, this will have a 45 because they're the same variable, and then you'll be able to do the operation. Okay, so but the place where you put it is up here, because what I could do is, let's say I want to perform this operation several times, right? I want to calculate the sum of let's say the money. Let's say that's money that you made last year, or no, let's say the money that you made in the first 6 months of the year versus the money that you made in the second set of 6 months of the year. So in 2019, let's say you made in the first 6 months, you made, you know, $12,000. In the last 6 months, you made $45,000. Right, and so you would be able to then just run it there, right, by calling show sum. It's like a calculator almost, right? And then this is for 2019. Now you want to do the same for 2018. So you can use the exact same function, right? You can do show sum, but now you just need different values. You need, let's say that you made 7,000 and 18,000, right? And so as you can see, you can do this for every single year going back to 2000. ... Right? You can do that, and you don't have to write this 20, 30 times. You only write it one time. But this one, the call, is the one that you have to do however many times, because each time you have to give it a set of parameters. Right, so let's say in 2017, you actually made more, and so on. Does this make sense, guys?
Yeah, you're explaining everything very well. I know all this, I know modules and everything because of having a background with the C libraries. And you're explaining everything extremely well for everybody.
All right, great. So let me know if there's any questions, okay?
So would I have to change the display? So let's say I went and I put the call sum and then for 2017, and it'll be $7,000, $18,000. For that say display the sum of 12 and 45, would I have to change that display in my main module?
Yeah, you would, the way that it's set up. You would have to change that because the display is basically hard-coded in.
You
It
mean
doesn't
this?
adapt.
You mean that?
Got you. Yeah, so I just have to change my display away.
That's what you meant. So actually, let's do that. That's a great exercise, right? What do you guys think? How could we do what he wants? I get what he wants. So we're talking about everything from 2000 all the way to 2019, right? And he noticed this problem, right? That it's always going to say 12 and 45. So how would we fix that so it actually displays these values for each year, the respective values for each year? What would be the simplest solution, do you think?
What you would do is you would take your display for the sum and you would take that and put that into your module. So you would say the sum of, and
What's
you would
num2?
do num1 and num2 is, and then the result.
You mean that?
Yes.
Yeah, very good, right? So you take it out of here and you put it in there, and then what she says is do display, and then the sum, right? And then let's just use a comma of, what is it, num1, right? Comma, and quotes num2, comma, is. Do you guys see that?
Yeah.
Make sense?
Yep.
Yeah, it does.
Yeah. You can see how that, you know, it's a simple solution, right? And what you just did again is modular programming. Instead of, you know, you had a problem there and you're trying to figure out, oh, how do I do this efficiently? Well, pretty simple. Just move it into the module do it once, do a little bit of coding here, right? But that's what programming is about. It's about building things, and that solves it pretty easily. Great questions. Are there any other questions? All right, so it seems like there's no questions. Let's keep going then. All right, so here is your nemesis. All right, so by value versus by ref. All right, so what's the idea here? So as I said, we are actually not going to be using this in Python. Python just doesn't really use it. I can never remember a time when I've actually needed to do that, but this is very strongly used in C++. Okay, so at least more so, a lot more so. So what is the idea here? So the title is passing arguments to modules, right? Pass by val versus pass by ref or by reference. I keep calling it by val, by ref. What I meant is by value or by reference. So to pass by value means that only a copy of the argument's value is passed into the module. You literally, whatever it was outside, you make a copy of it and you pass it. One directional communication. Calling module can only communicate with the called module there, it says. All right, and so that's sort of the idea. You only pass it in one direction. Pass by ref or by reference, by reference, means that the argument is passed into a reference variable. Okay, it's two-way communication. Calling module can communicate with called module, and called module can modify the value of the argument. So it's sort of like saying there's a link, or some people will say, there's a pointer, or other people will say, I have an address. And really, probably the more correct way of looking at it is I have the address of a place in memory where I have that value. And so what you're passing is, in a sense, the address and not the value itself. But it has implications, actually, when you do by val versus by ref. In particular, if let's say other people, other programs are using these variables, it has strong implications, whether you use by value or by ref. And we will see that. So let me use, since I have some white space here, that concept of by value and by ref. So for instance, I pass something by value. And what I mean is, I passed a copy of it. So now A gets 7. This came from some A outside, whatever. But if I change that to 9, I'm only changing like my local copy. Something by ref can have the implication that you might be passing the same A, but it's an A located somewhere in memory. So technically, this is still pointing to that. You see, that's the idea anyway. And so if I now, I should have done this A over here remained at 7. Whereas over here, this A may have been 7, but if now I do A9, that A9 may be changed. You see that? And so that's really one of the implications that sometimes when you're dealing with this by val, by ref for the first time in a programming language and you're not so sure how it works in particular for that language, you might have this unexpected behavior, okay, of, hey, what happened to my value? It changed, it didn't change, what's going on? And, it has implications there. We will not be using this concept that much here. You will certainly come back to this idea in other programming languages, but just be aware of the concept for now. This is just an introduction of it. And as I said, in Python, not used that much. At least, it's abstracted. That's what I want you to understand. It's abstracted quite a bit. Are there any questions? No questions?
So I mean, by ref is basically that you had A in your memory before. So if you change A, it'll also change no matter what. And then
Yeah,
by
so
value,
in particular, if I have like process 1, process 2, right? This idea of by ref, they might both be referencing the same thing. So this happens sometimes in Python. It happens in certain situations, it will, but it's kind of, we don't use the word by val, by ref. It's more about understanding what is happening, that you have this process. If this one changes it, it can also be changed for this other one. Do you see that? Whereas with by val, as it said, you're making a copy of it. So it's a second, oops, sorry. Pass by value means that only a copy of the argument's value is passed into the module. Pass by ref means that the argument is passed into a reference variable. And it sort of gives you this two-way communication. So the calling module can communicate with the called module, and called module can modify the value of the argument. So, sort of implied there. Do you see that?
yeah,
Did I answer your question?
yeah, I got it.
Okay. So as I said, we're not going to be using this that much. There might be some issues with this in your homework assignment, but that's, for now, I want you to understand that. It's like there's a second version of it with by val. With by ref, there's only one. Now, you might ask yourself, why do that? That's kind of crazy, right? Why do you need that? Just always make a copy. Well, it turns out that sometimes, well, first of all, in a language like C++, which was designed for efficiency, sometimes you have limited memory. And so you can't really afford to start making multiple copies of everything, right? Because you're going to consume a lot of memory. So in the sense, if you're careful with what you're doing, you won't have any problems. Things can be by ref. And instead of making, 1, 2, 3, 4, and so on copies, you actually only use one. And as long as you're aware of what you're doing, you won't have any issues. However, I won't deny that having this idea of by val, by ref can sometimes, if you're not careful with your coding, you can end up making mistakes and errors, right? So that's a possibility. Okay. All right, so global variables and global constants. So a global variable is accessible to all modules. That's pretty much the definition of it. As I said, you guys will use global variables quite a bit in the beginning. As you start moving through the years, you will notice that you use them a lot less. But in the beginning, oh, there it is. Should be avoided because, there we go. So a global variable should be avoided because they make debugging difficult. I agree with that. You want it. Modular programming basically implies that every module is a unit that's independent. You only need to care about the inputs and the outputs, and you can almost treat it as a black box, etc. When you have global variables that affect that module, you get into debugging issues. You might forget about a variable, you might miss it. It might be by val, by ref, and if it's by ref, some other module may modify it. You weren't aware that it modified it, and now your module does not work. You see that? So it does create a little bit of a problem. So in general, they should be avoided. But in the beginning, the programs that we're doing in this class are so simple that you can use them, sure. Making the module dependent on global variables makes it hard to reuse, right, in other programs. And that's very true because, say you have a whole bunch of global variables that you're using in there, you know, it's going to complicate things for you, right? And so you got to be aware of that. So you want to make things more modular, you should avoid global variables. They can make a program hard to understand. You know, it's kind of repeating itself at this point, but that's the general idea there, okay? A global constant is a named constant that is available to every module in the program. These are okay because these are, you use these quite a bit. Let's say that you're building, you're reading a sequence of data. Let's call it a batch, right? So we're reading batches of you know, 64 rows, right? So, you know, it's always 64. And so that's a constant, right? So you specify that kind of outside, that's the definition of something, and you're always just using that. So this is actually better to do it that way, because if you're using that variable batch throughout your programming, throughout your different modules, you don't actually have to change every entry of batch. You just go to the top where you set your parameters and you change it there once, and then it's going to take effect for everything else in your code. Since a program cannot modify the value of a constant, these are safer than global variables, and they're usually okay, as long as you only have one entry of it, right? And it's a constant. Now in Python, do you have to use a specific constant? No, usually you just use a variable of any type, but you give it a number and you never modify it. And in essence, so like I just said, usually what I would do in Python is I'll just write batch 64, and that's it. You know, I might write a comment and say, you know, number of batches. And I just know that this serves the meaning of being a constant. It won't be modified by the code. I may modify it because my memory cannot support 64 batches of anything, so I have to reduce it to 16, let's say, or something like that. Okay, so that's the general idea there. Oh, and that's it. That's so that's the first set of slides. That's the module. Okay, the next set of slides. So are there any questions before we move on to the next set of slides? As I said, these are very short chapters actually, and they're all kind of related, or they have a common theme. Okay, so it seems there's no questions. So let me go ahead and start up the other set of slides, which is functions. So in your book, this is these are chapters 3 and 6, and then in the Python Gaddis book, they're in chapter 5. So I don't know why, but they're all kind of the same ideas, and they're, as you've seen so far, they're pretty repetitive. So when we get to the Python slides, I'll skip the slides I've already covered and just focus on the new ones. All right, so what slides are you currently looking at? Guys, what slides are what slides?
Now the first slide of chapter 6 functions, starting out with programming, logic, and design.
All right, great. So functions then. All right, excellent. So we're going to look at functions now. As I said, you know, pretty similar topic. So I like to just, you know, merge them together. So functions is here, as you can see. So one thing that's new here in functions is really that we have also not just functions that we define, but every programming language is going to have what are called libraries. All right, in C, C++, you know, those are the, you know, you import libraries as well. You know, your standard input, output, and all of that. In Python, it's going to be import. Okay, and it's going to be the name of the library, whatever it is. And this is where Python shines. Okay, Python has, I am not kidding about this, pretty much a library for just about anything you can think of. If you can think of something, Python will have some library, and you can build your own libraries easily. And so this is the power. So what are libraries? They're basically the same idea that we explored in a second ago, modular programming. But it's modular programming where other people have built these modules or functions, and they create them as libraries, and then you can use them in your own program so that you don't have to write all the code. So usually that's the way that programming works, especially with scripting languages like Python, is actually you pick a library that you're going to be using and you use the functions that are built in, and then you work through those. Okay. Usually when you're starting out, the main library that we're going to play with is the math library, right? So, you know, we all take, you know, you guys took a lot of math, you know, in your schools. And so you're accustomed to using all of that. And now we just, you know, we'll play with some of that. But that's basically what it is. So that's really one of the main topics of this that's new. Otherwise, it's really just writing your own functions, right? Writing your own functions, which is something that we actually did last Thursday, and we're just going to reinforce that a little bit more. And one example that the book focuses on is random numbers, right? Generating random numbers. So when you guys take your ITS140, which is cryptography, right? You know, like if you know familiar with you know, scrambling your information so it's secure, right? You will see that when we start to look at primitives of cryptography, you know, randomness, it's important, okay? And so because that provides, that's really the main mechanism for security. And so we will be exploring those things. But here, the book just kind of gives us an introduction of that. So let's, you know, first thing, let's start with a formal definition of a function, just so we have something to work with. So we already talked about a module, right? So you know what a module is now because you have that definition, and you can always go back to that. So a function is a module that returns a value. That's it. As you saw before in the previous slides, we just had like print statements, we had operations, certainly, you know, add some, you know, sum, things like that. But we weren't returning any values, whereas here we are, okay? So in defining a function, defining a module in Python is pretty much the same thing, with the difference that the function will have this last statement where you can return a value. So a function is a module that returns a value back to the part of the program that called it. Many languages provide libraries of functions that you can use. And the book just really goes heavily into this idea of random number generator. I don't know why it actually goes into it so strongly, given that this is one of a gajillion or a billion different things that it can do. So a function is like a module, but it returns a value that can be used in your program. Now, library functions, these are written functions that come with most languages. And that's the other thing, that you have libraries that come with Python itself. You will see that, you know, when you start up your Python, you can do import OS or import RE, things like that. And those libraries are built in. But there's an additional huge library of, or there's an additional huge set of other libraries that you can also import. So there's going to be NumPy, which is really big. NumPy, If you take ITS140, you will learn all of these libraries, and they're very, very important for data. You guys nowadays live in the world of big data, right? Big data, which is, as the name implies, you just have to process, millions, billions of records. And so you need to do that more efficiently. So there's a lot of libraries out there that you can use and import, but they have to be added to your program. So for instance, in Anaconda, which is what we've been using, if you go to the Anaconda terminal or shell or command prompt, one of those, I think is the name in Windows, and some of these libraries are not built in. You have to install them. So in Conda, if you're in the prompt, you just have to type, once you've created an environment, you create conda install, and then, something like numpy, right? And it'll do it for you, right? And so, but the problem is that there's versions, so 1.12, but there might be a numpy 3.7. And so your question is, which one do you use? So usually when you're starting out, the most recent. But when you have specific tasks, you have to do a little bit of research first before you decide on which one you're going to use. So libraries is a huge topic, okay? It's a huge topic. It's quite straightforward. You could literally have a class just on learning one single library in Python. So for instance, we could have a semester course just on learning how to do, you all know Excel, for instance, right? So you know Excel, and Excel is about like manipulating data. So if you wanted to manipulate, so this, although this is not quite like Excel, I'm using this as an analogy, but but there are libraries, let's say in Python, that allow you to manipulate data, sort of like the analogy of manipulating data with Excel, only programmatically in Python itself. And we could have these are, there's one, they have funny names too. That's the other thing. They have funny names, like one is called pandas. I don't know why. And so we could spend a whole semester course just on pandas, maybe NumPy together, and NumPy, they all, a lot of them have this pi, right? So because it comes from Python. So it's like NumPy, SciPy, crypto, or PyCrypto, you'll see that a lot as well. And, for instance, right? And so they're usually named like that, but some are just named pandas or TensorFlow or sklearn, whatever. All right, so my point is, certainly in all programming languages, libraries are huge. What are they? Could you write all the functions in the world? No. Other people that specialize in a specific task create a whole bunch of functions and modules. Then they think, I'm going to make these more organized. They end up creating a class, something they call in object-oriented programming. And then eventually they create a library, and then they just show you how to use it. And then you can always use that from your own programs, right? So certainly Python it excels at this. But anyway, so library functions are written functions that come with most languages.
What happened?
Yeah, can you guys hear me?
I can.
Yeah, you're back. It was like you were in the middle of talking, and then you just stopped talking, and I'm like, is it me? And I
Yeah.
look, and I'm like, no, it's not me.
How long was I
Thank
gone?
God.
How long was
For
I
about
gone?
like 30 seconds.
Oh, only 30 seconds. Okay. All right. Yeah. So it just now Zoom is a little bit better, and at least it's good at telling me when I left. So I knew immediately that it cut off, and apparently it's pretty good at restoring everything, because I think the recording is still going. So
Yeah, it said Jack became the host and you were just gone.
I saw that too. But it seems like, as I said, as Zoom matures as a product, yeah, I thought my internet was out. So they recovered quite easily. So that's good. So the recording should still be going, so I think we can just continue. And as you guys said, it was only like a 30-second break there. All right, so where was I? What was the last thing you guys heard me say? Do you remember? Library functions, is this the last thing that you think I was talking about?
Yeah, I think so.
Yeah,
I think it was library functions.
Yeah, it was.
Okay, great. So I'll pick up here then. So as I said, so in conclusion, you know, there, as you can see, the last statement, it just says, usually for common tasks. So the best example that everybody uses usually is math, right? We're all familiar with math. So, and there's a lot of functions in math, trigonometry, you know, calculus and linear algebra and things like that. And so we can use a lot of that. They save time for sure because you don't have to write things from scratch. And it allows a lot of code reuse, which is really important. Okay, great. All right, so here's an introduction to functions. The random number generator function is useful in, and like I said, this is just an example of one of a million possible functions. So here, you know, we could use it for games, simulations, statistics, and computer security, as I said, encryption. You will actually, you know, when we take your crypto class, you actually see a lot of that. So the idea with random, how random functions work is, you know, and by the way, they're not actually 100% random because computers are deterministic. So they're what is actually called pseudo-random, which means that they're kind of random, but they're not 100% random. To achieve 100% randomness, you would need to literally, you know, have some kind of what is called a seed, some kind of an input to the function that comes from some outside source, like, you know, and it's very difficult to find out something that's actually random in the physical world, but something. Decay of a particle, maybe, something like that. All right, so so how random, oh, go ahead, somebody said something. I have always a hard time getting into this chat, so that's why it takes me a while. Huh. Okay, so don't worry about the function so much with the random number generator. You know, just this is just an example to illustrate the use of functions. But you can see here, the whole idea is, oops. The whole idea is you have a variable, and now you might ask yourself, so where did this word come from? Random. And so it's, you know, it's not a reserved word, it's actually a function in the system, like a built-in function, where you specify a set of arguments from 1 to 100. So you're going to pick out of that range from 1 to 100, one number sort of at random. So 1 and 100 define the range of the number that can be returned and are called the arguments. The function is called and a random number is returned and assigned to the variable number, as you can see that. So let's say 17. So that's equivalent to the variable number getting the value 17. All right, so now this is the thing that's more relevant to us in this class, because we don't want to focus so much on libraries this semester. You'll certainly have a lot of time for that in other, you know, as you use Python more or other programming languages in the future. But here we're just writing, you know, writing your own functions is really our goal, right? So we saw an example of this last Thursday, and it's pretty much the same thing. You'll write a function. It'll have the function header, the body, and the most important part for it to be a function, the return statement. So the function header specifies the data type of the value that is returned, the name of the function, and any parameter variables. The function body are the statements that execute when the function calls, and then the return statement just specifies the value that is returned when the function ends. So obviously that's better explained or understood by looking at an example. So you can see here, this is just a module, right? You should understand all of this now because you've gone through chapters 1, 2, 3 at this point, and 4, right? So you've done the first 4 chapters of the book. So this should be very clear. And then down here, you have a function. Now notice that the keyword has changed now in pseudocode. Remember, in pseudocode, from module to function. Notice also something interesting. You put a data type here. Now, in Python, you don't have to do that. But in other languages, I actually like how VB does it, where VB, Visual Basic, would have done it like this, int, and then, function, and then something, right? So sort of kind of like before in a way, but, there's different ways of doing it. So as long as the information is there, it doesn't matter. So here we have function integer, which is the data type of the variable that would be returned. Then we have the name of the function sum, and then we have the parameters here, the arguments that we would use inside the function. Okay, so this is pretty much the same function we saw before. You can see it's just the result is there. We have the set, and then we now return. Okay, so in a sense, we take we have this function. We take this function here that takes 2 values, adds them, and returns something. Now, keep in mind, we can have 1,000 operations in there, right? So it doesn't just have to be 1 or 3 or 4. It can be a lot more. Now, the other relevant thing is in the module here, we now need to call that function. So you can see here we have some variables, have a display, take an input, another display, another input. And then here we have, what is this? What is that? Who can tell me? What is that?
Integer?
Well, the whole thing. What is this whole thing?
Oh, the set?
Yeah, the whole thing. Like the whole thing. What is it?
What the fuck it is?
What is this? You see the relation to that?
Yeah, the sum, the result.
It's the function call.
I was about, dang it, I was about to say it.
All right, yeah, so this is the function call. What does that mean? It means here, and I'll write it here, this is the function call. Whereas this is the function, what is this called? The function what? It's the function definition. So you define the function there, and then it's somewhere else in the so in the module itself, you call, right? So you do sum, right? And you call it. Does this make sense, guys? This is what's important about this code. Hopefully you see everything else we've done before, but in particular, we call sum. Because sum returns, we need some way of catching the result. So the result gets assigned. What's the name of the variable that the result gets assigned to? What's the name? It's right there.
Repeat the question.
What is the name of the variable that the return result here is assigned to? What is the name? So when you call sum executes, it returns, and then the value that it returns, it gets assigned to a variable, right? What is the name of that variable? Can you guys, I mean, it's an easy question, guys. Can you hear me?
The result? Yeah.
Yeah, so you call, okay, so you call sum, correct?
Yes.
Okay, and it takes as its arguments first age and second age, right? Whatever they are, you enter those on the console, right? So let's say 10 and 20, right? Everyone with me so far? So then that 10 and that 20 are here, right? Because they're here. Yeah? Guys?
Yep.
Okay. So you then
Yeah.
add them, and that's 10 plus 20 is 30, right? That's in result. And then you return. So where does that 30 go? Once you finish this code down here, you're done end function. You calculated 30. It function sum returns. What variable does that 30 get assigned to?
Total.
Total. Okay.
Total.
All right. I was worried there. All right. Yes. Very good. So it gets us.
Sorry, I didn't understand the question. I was like, wait, what?
Yeah. No, all I'm doing is going through, let's go through the flow of this program. Let's go through the flow of it. And you can see it down here, right? So declare first age, second age, and total. We have 3 variables, right? 3 variables. Then we do enter your age, first age. So there you go, 22. Then it says, so this, right, 22 here. Then display enter your friend's age, second age. Enter your friend's age, okay, 24. Right? Then you go into this statement here. So that's 22, that's 24. You call sum, right? Where is sum? What is sum?
46.
Not the answer, but in the code definition, where is sum? If I see, because
Sum is the function.
Yeah, it's the function, right? But let's say that I'm the interpreter. I'm not very smart. I look at the word sum and I'm like, okay, what is that? If I look at first age, I know, oh, it's that one. If I look at second age, oh, it's that one. If I look at total, okay, is that one. But what is sum? So the interpreter will look, you know, I don't recognize it. I don't, oh, it's the function, right? You guys see that? See it right there, correct? So then what you do is you jump. It's like you jump from here to the function definition. So what is the value of num1 now? What will the value of it be? Num1.
Won't be 22.
Very good. What's the value of num2?
24.
24, very good. So then I go in here, num1 plus num2 is what?
46.
46. And that gets assigned to what variable?
Total.
Total.
Not yet. Currently, I'm in this statement here. I haven't
So
made
result.
that to result. It gets assigned to a result. 46, right? Then the program does what? Return. And it returns what? 46. 46. So where does it return?
To the module.
Which module? Tell me in the program which line from 1 through 25, which line does it jump back to?
13.
13. Why 13?
Because that's where you're calling the function.
That's where I'm calling it. So you have to think of it that way, right? It's sequential. It gets to that point, calls sum, it finds it over here, jumps there, executes that. When it returns to the statement that called it. and it returns actually the value 46. So now this, you can pretty much assume, I'm going to like say like this. You can assume that all of that becomes just one thing. What is that one thing that all of that becomes? What would that be?
The function?
Not the function. The function is over here, the function definition. But when it finishes executing, it's got the 46, it returns over there. The whole thing becomes
Total.
not total. Total is this one, right? What do you think?
I don't know if it's right, but it's the call. That's the call statement.
This is the call statement. I'm not saying it's going to disappear. I'm saying that when this function finishes executing, because it's a function, it will become just one single thing. The return value. The return value. What is the return value?
The sum, right?
Which is what?
46.
46, yes. So what I'm trying to say is whenever you think of this, of a function, think of it this way. Sum, I'm going to say first age, second age, right? That's how it is, and the code does not change. But remember that these are things sort of like in memory. So this is equivalent when the function return finishes and it jumps back over there. This is equivalent to just 46. Do you see that? Now, it's not that the code will change. That's static, right? That's just you writing code. But when the program is executing, the entire function has a purpose, a calculation, right? Does all of its magic, and then the sum of it is just the fact that it's 46. That 46 gets returned to somewhere where the program is running, right? Where the initial call came from, which is that. So you can, in essence, think that this, where the values were what, 22 and 24, right? This becomes that. Is that clear, guys? Do you guys see that?
Yeah.
This is during runtime, right? When it's executing. Does the code actually magically converts itself to a 46? No. I'm talking about execution-wise. That's how you can think of functions. Do you see that? Are there any questions? This is a concept that maybe it'll become more obvious later on. You'll be able to replace things. You'll be able to replace, for instance, this first age might be some complex value. And so, something, and so you might just replace it with a function. Function, barometric pressure, right? And it's a function that just returns a value. So in essence, it's some complicated number that gets calculated, but you'll be able to just plug that in where variables are, and it'll work just the same. Because of this idea that, because a function returns, you can just imagine it is whatever the value is in it. Okay? Are there any questions so far? Comments?
I have a sort of a comment. For the homework assignments, during class I went and I looked at my my Jupyter notebook, and it turns out I was actually putting it, because I have a lot of practice with the C library and everything. I was actually breaking down the homework assignments into functions and just doing that.
That's fine. I don't have a problem with you don't have to do, as long as it's right, you know, it's okay.
Okay.
No problem.
I just wanted to make sure that would be allowed.
Sometimes, yeah, I get what you're asking. It should be fine. Sometimes there may be situations where I can see how, for instance, I would say, use a list, for instance, right, to solve this problem. And because of your knowledge, it's just an example of dictionaries, you're going to give me a solution with dictionaries.
Yeah,
But-
because I looked up for the previously talking about the flowchart for the Roman numerals, because it's all kind of the intended way, I guess, to do it would be a bunch of if-else statements, and that's why you have that really big flowchart. I'm like, why don't I just do it in a case? But then I look online and in Python, it's like, no, there is no direct translation for a case statement in Python itself. So you have to build a dictionary, and I started looking into that, and I was actually confused.
Yeah, don't do that. So,
but I know we're going to be covering that later, so I went and I scrapped everything.
But even, you know, even I meant actually kind of the opposite of that. I ask you to do it the more complicated way with a list, let's say. But because you know dictionaries, you give me the solution with dictionaries. Keep in mind what I wanted you to do in some example that is hypothetical is to actually do it in the list way to practice with that. You know what I'm saying?
Yeah, I do, definitely.
Yeah, so sometimes it's okay. Sometimes ask me maybe just to double check, because there might be a different goal. But yeah, in general, it should be okay. Remember, with Python is the elif, right? I think we did an example of that.
Yeah.
Last week, right? And then the last one is else. And then the first one is if, and you can have as many elifs as you want in there. Okay? All right, good. So where were we? All right, we're almost out of time. So I think these slides, I'm almost done with them anyway. Writing your own functions. Okay. More libraries, functions. Okay. Yeah. All right. So we will cover those on Thursday when we do our lab. I'll do that, and then I'll go over the Python notes, okay, as well. So this is a good stopping point. I'll stay a couple of minutes if anyone has any questions about anything. Otherwise, I'll see you guys on Thursday, okay? So have any questions, go ahead.